We now write an equation of the circle which satisfies these conditions. That is, the center of the circle should be in the first quadrant, and this circle should be a tangent to the line x equal to negative 3, x equal to 5, and x axis. So here I have drawn the sketch of the circle with the center in the first quadrant. And for this center, the lines x equal to negative 3 and x equal to 5 are the tangents, as we can see from this diagram. Also, the line x-axis, that is the equation of the x-axis, is y equal to 0. So these three lines are tangent to the circle. And in this case, we have to determine the equation of this circle. Okay, so first let's determine the coordinates of this endpoint or the point of tangency. This is the point where the tangent, that is this line, touches this circle. So therefore, we can see its endpoint is the coordinate of its endpoint is negative 3 comma y. And similarly for this tangent, that is x equal to 5, which touches the circle at this point of contact, we can say its coordinate is 5 comma y. So first we have written these two endpoints or the coordinates of the point of contact of the tangents. And basically this gives the endpoints of the diameter of the circle, and so we can determine the length of the diameter. So first let's figure out the diameter, and this basically equals this distance, that is from negative 3 to positive 5. So we can do this subtraction, that is 5 minus of minus 3, and this equals 5 plus 3, that is 5 plus 3 equal to 8. So the diameter of this circle is, we have figured out, it is 8 units, and therefore we can find the radius of the circle. Radius is half the diameter. So I take the half of this 8, which equals 4 units. So we found that the radius of this circle is 4 units. Now we shall find the center of the circle. Notice that we can find the center of the circle using the midpoint formula. That is, these two are the endpoints of the diameter. So obviously the center is the one which lies exactly in the middle of the diameter. So when we use the midpoint formula, we can find the coordinates of the center. So using the midpoint formula, I find the coordinates of the center. And so this equals, we have to add the x coordinates, that is negative 3 plus 5, and this has to be divided by 2. Negative 3 plus 5 divided by 2, as well as the y coordinates, that is y plus y divided by 2. Remember that the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 by 2 for the two points x1 y1 comma x2 y2. So basically I'm using this formula to write the coordinates of the center. Now let's simplify this. So this equals negative 3 plus 5 is 2 by 2, and this is y plus y is 2y divides 2, and so we get the coordinates of the center is 2 by 2 is 1, and this is y. So it's basically 1 comma y. So I can write down the coordinates of the center as 1 comma y. And notice that this y is basically this distance, and this distance is equivalent to the radius of the circle. Radius, we have already figured out that it is 4. Since it is just above, or we have the tangent at x-axis, this point or the distance is at 0. So from 0 to the radius is 4. So obviously the y value has to be 4. So therefore finally we can say that the coordinates of the center of the circle is 1 comma 4. This is the center. Now using the center and radius information, we can write the equation of the circle. That is Let's copy the center, which is 1 comma 4, and the radius is 4 units. So let's put this in the general equation of the circle, which is x minus h quantity square plus y minus k quantity square, and this equals radius square, where h comma k is basically the center, that is h comma k equals 1 comma 4. So therefore h equals 1 and k equals 4. Now plugging this h value and k value, also the radius, we get x minus 1 quantity square plus y minus 4, and this is quantity square, and this equals radius square, which is 4 square, and we know that 4 squared is 16, so I can put this as 16. And so this is the equation of the circle which meets the given conditions.